Hello everyone, this is Vasant, a nine-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve questions on fluid mechanics from quiz 2 paper of fluid mechanics of IIT Bombay. So this is the whole question paper. Let us start solving the question. The first question over here is, if a tank partially filled with water is being carried on a truck moving with a constant acceleration, the level of liquid in the tank will rise on the rear side and fall on the front side of the tank, fall on the rear side of the tank, remain same on both sides of the tank, rise and fall alternatively on front side of the tank. So the fundamental equation of statics is grad P, means gradient of pressure, is equals to rho into x bar, where x bar is body force per unit mass, right? The body force in case of fluid is mg divided by mass is m, so that will be g bar, right? So grad P will be is equals to rho into g bar if the tank is in rest or moving with constant velocity. But here the tank is moving with some certain velocity. Suppose let us take the tank is this one. If it is at rest or moving with constant velocity, then the free surface will be like this, right? And the g bar will be like this. And pressure will vary in this direction, and perpendicular to this direction the pressure will be equal, right? So in this horizontal plane the pressure will be equal, but in this case the tank is moving with constant acceleration a. Here we have g, the tank is moving with constant acceleration a bar, right? So now grad P will be is equals to rho into x bar minus a bar. Okay, so now grad P, gradient of P will be is equals to x bar plus of minus a bar, right? So this is resultant of x bar and minus a bar. So g, x bar is g bar, this is g bar. So g bar is like this and minus a bar is like this, right? So resultant of these two things is something, it will be something like this. Suppose this is r bar, okay? Then grad P will be is equals to rho into r bar, right? So if you see, the pressure will vary only in r bar direction. In perpendicular to the r bar direction, the pressure will remain constant. So the pressure will vary in this direction. Perpendicular to this direction, the perpendicular direction will be this. So pressure will be constant. Constant pressure, right? So these are equi pressure lines, right? So the free surface will be something like this, because the free surface will be perpendicular to the resultant value of body force per unit mass of this, right? So iska resultant is in this direction. So the perpendicular direction to this resultant will be something like this. So the free surface will be something like this, right? Because when A is 0, the free surface is something like this. When A is 0, it is perpendicular to G bar. Now it will be perpendicular to the resultant acceleration of G bar and minus A bar. Okay. So free surface will be like this, means it will go something like this. The body is moving in this direction, right? So it is fall in front side, rise in rear portion, rear side. So this is the answer. Rise on the rear side and fall on the front side of the tank. So now let us go to the next question. The atmospheric pressure on the surface of an oil tank of specific gravity 0.8 is 0.1 kg per centimeter square. The pressure in meters of water at a depth of 7.5 meters. See, kg per meters centimeter square. Actually, pressure is Pascal, right? SI unit. That is Newton per meter square. Means that will be kg per meter square into meter square by second. But here only this value is given. So this can be written as 10 power 4 kg per meter square, right? So if you want to convert it into pascals, it will be 9.81 into 10 power 4 kg per meter square will be equals to 1 pascal, right? But no need of converting it into pascals. Let us do this. See, the pressure at depth 7.5 will be equals to P atmosphere plus rho W G into H, but we are putting it in kg per meter square. So we are neglecting G, right? So we just write this as 0.1 into 10 power 4 kg per meter square, and we write this as rho of oil into H. So that will be rho of oil is 0.8 into 1000 into H is 7.5, right? This is the pressure at 7.5 in kg per meter square. So it should be, it is equivalent to some meters of water. So suppose a column of waters of height capital H. This is water. Okay. So then the pressure will be equals to rho W into H in kg per meter square, right? So that will be equals to 1000 into H. H is in meters. So H will be equals to 0.1 into 10 power 4 divided by 1000 plus 0.8 into 1000 into 7.5 divided by 1000. So this will be equals to 1 plus 0.8 into 7.5. So this will be 1 plus 6, that is 7 meters of water. Okay. So now let us move to the next question. This is the next question. A swimming pool has inner dimensions as 24 meters into 9 meters into 2.5 meters. It is filled with water up to 4-meter depth. Find the hydrostatic force due to the water on bottom of the floor. See, it said that in depth direction it is filled up to 4 meters depth. See, if you see, one is 24 meters, one is 9 meters, and other is 2.5 meters. Nothing is mentioned about length, breadth, and height, right? If you take 2.5 as height, then it is impossible, right? Because you can't fill it up to 4 meters of depth. So either the depth should be 9 meters or 24 meters. So nothing is mentioned. You can take any one of that, but it makes sense when you take 9 meters because they can see a swimming pool with 24 meters depth and 4 meters of water is quite important because this will be 4 meters. Then if 24 meters is height, then it will be some look like this. This will be 4 into 5, 5 times of this length. So you will jump from here. So it is not making sense, right? Means you may take that value, but I prefer to take 9 meters as the depth and 24 meters as the length, 2.5 meters as the breadth, right? So 2.5 meters as the breadth, 24 meters as length, and 9 meters as depth. Okay. Then the pressure at the bottom will be, here it will be atmospheric pressure, this value. This is 4 meters, right? And this is 24 meters, and this is 2.5 meters. Right? So नीचे से भी, so see the pressure at the bottom, the gauge pressure will be T gauge will be is equals to rho W to G into H, right? Density of water is 1000 into G is 9.81 into H is 4 meters. So the value will be 1000 into 9.81 into 4. So that will be is equals to 39240 pascals, right? We need to find out hydrostatic force. So hydrostatic force will be is equals to 39240 into area. Area of bottom area is 24 into 2.5, right? So this into 24 into 2.5. So we are getting 2354400 newtons, right? So that will be is equals to 2.3544 mega newtons. So this will be hydrostatic force. Okay. With this, we complete today's lecture. In next lecture, we are going to solve remaining problems of this quiz 2 paper. Thank you.